Okay, so this video is going to be on how to actually graph now that you know all the rules and how to calculate slope. Okay, so it doesn't tell you in the notes that this graph is based off density, but based off of your knowledge on density, we have a volume and we have mass here. Okay, and you know that density is equal to mass over volume. So we can kind of conclude that this slope of the line and this graph will tell us what the density of this object is. Okay. So it's telling me that my x-axis is volume. Okay, so I'm going to go ahead and put down here volume. And I need to make sure that I'm putting milliliters because that's my units. I'm sorry you can't see it. Okay, volume, milliliters is my units. Okay, and then my y-axis is mass. Okay, so mass is in grams. So I'll need to label that as well. All right, next thing, we need to put a title. Okay, now you need to remember that we always say the dependence of the dependent variable on the independent variable. Okay, so this title of this graph will be the dependence of mass on volume. Okay, so that's going to be the title of this graph. All right, next thing we need to do is put numbers on the x and the y-axis so we can start to plot. Okay. So volume is, I have a number from 1.5 to 10, and if I was to count my spots down here, I bet I could go up by 2s to get to 10, and I'd be okay. So let me just make sure. 2, 4, 6, 8, 10. Oh, I have more room, so let's see here. Maybe I can do 1, 2, 3, 4, 5, 6, 7. Yeah, looks like it's going to work. So I'm going to make this 0. I'm going to go 1, 2, 3, 4, 10. Okay, so there's my x-axis. Y-axis, I'm from 4 all the way up to 27.4. I already went ahead and counted. There's 30 lines here. So I'm going to just go up by 5s here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this would be 10. 1, 2, 3, 4, 5. This would be 15. 1, 2, 3, 4, 5. This would be 20. This is 25. And then this guy is 30 up here. Okay? Now that I have my lines, I can go ahead and graph. So let me zoom out here for you guys so we can see this whole graph and what's going on here. Okay, so my first plot is 1.5 and 4.1. So I have 1.5, here's 4, so I'm right here, 4.1. Okay, I have 5 and 13.5, so I'm going 5, 10, 11, 12, 13, 13.5, so I'm right here. Next is 7.5, which is right here, up to 20.2. So I'm going to make sure I'm right here. 20.2. 8, 21.6, so 8, 21.6, and then 10, 27.4. So here's 25, 26, 27.4. Okay, so all my plots are plotted here, all my data points, okay? Next thing is to draw a line best fit. So you're going to need a ruler for this. And if you remember line best fit, we're doing we're going to try and do equal numbers on top and bottom. However, I have 5 numbers here, so we're going to try to do 3 and 2 to make sure we can average it out. Now, if I don't have a 0, 0 point, I'm not forcing it through 0, 0. Okay, it's not a data point, so I don't need to make sure that my line best fit goes through 0, 0. Okay, so let's see here. I look like I can get a pretty good line with 3 on the bottom and 2 on top, okay? So there's going to be my line best fit, all right? You'll notice that my line is barely touching the top of this point, and that's okay, okay? But this slope here, or this line best fit, is going to be then what I calculate slope off of, okay? I'm not calculating slope off of the data points that are given to me because I'm trying to find the average of all of the data points, okay? So now let's calculate slope. So you can do this one of 2 ways. So I can do m is equal to rise over run, or I can do it's equal to y2 minus y1 is divided by x2 minus x1. Okay? So let's do this math here. So I'm going to do, first thing I need to do is find 2 points on my line best fit, preferably through an origin so I can find the value easily. Okay, so I have a point here that's through the origin, and I have a point here that's through the origin. Okay, so these are my 2 points that I'm going to use here. Okay, all right, so now let's do rise over run first. Notice that these go up by ones, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 as my rise, specifically 11 grams, right, because that's the unit, divided by my run, and these are going up by 0.5, so this would be 1, 2, 3.5, so this is 3.5 milliliters, okay? And if I was to plug this into my calculator, the slope of this line would be, with 2 significant figures, 3.1 grams per milliliter, because the units don't cancel, okay? So if I was to collect this data from a lab, this information is telling me that the density of this object is 3.1 grams per milliliter, okay? If I wanted it to do it the other way, if I wanted to do is equal to y2 minus y1 divided by x2 minus x1, what I'm going to say is my origin here is 2.55, and this guy right here is 616, okay? So then I would do 5 minus 16 divided by 2.5 minus 6. And if I was to do this in my calculator, it would be 11 grams divided by 3.5 milliliters, which will give me the same exact value that I got here. Okay, so that's how you graph and calculate slope from your line best fit. Thank you.